And welcome back. So the last time we were together, we made this, a simple cipher with a menu. And as we discussed in the last video, we're going to change this into a polyalphabetic cipher. So I'm going to show you some things that some changes I'm going to make. One change I'm going to make is I'm going to include a library so that I can have some delays between things printing. Things print a little bit too fast, so I'm going to use something called delay. So I'm going to say from time, that's a library, import sleep. And sleep is just something that I'm going to use as delay in printing. You'll see when I use this. Now, fixing string is going to stay exactly the same, so I'm going to keep all of that. And with get choices, when I run my current program, what I notice is that the choices are always at the top. And if I do something like enter a new shift number, it goes here and the menus keep running. And what I realized is I kind of wanted to have some white space in here, so I wanted to print a whole bunch of stuff to kind of clear the screen, if you will. So one change I'm going to make is up here in get choices. Instead of that first print saying just print, I'm going to say please print a new line. So I'm going to go like this, quote, and then it's a backward slash, and then n. Oops, it's supposed to be over here. Print quote backward slash, and then an n, and then repeat that 40 times. So I'm going to use times 40. So what that's going to do is when I want to print a menu, it's going to clear the menu each time. I'll show you what that looks like. So see how the menu is now at the bottom? If I enter a new shift number, what is the shift number? 6. It clears the menu. But you may have noticed that things don't stick around very long, so you can't really read everything. It is still there. If you scroll up, you can see it. But one of my ideas is to actually put a delay in some of these things. So whenever I have instructions or information for the user, I'm probably going to put a delay. Well, so the first thing we need to change to do a polyalphabetic cipher is with the code. So instead of it being called a shift, we're now going to have something called a code word. And this is the word that we're going to use to shift all of our messages. Okay? So we're going to have code word, and we're going to make it an empty string right now. And message will be an empty string as well. Instead of single quotes, I'm just using double quotes for consistency. Okay. So while choice does not equal 0, that stays the same. I'm going to say I chose 1. Enter a new, okay, so now instead of a new shift, I'm going to say enter a new code word. Remember, this is in the comments, so it's really just for me to remember what I'm doing. Enter a new code word. So shift is going to change to code word. Code word equals input. What is the new code word? Now, because the code word is a word, I have to actually fix it. I'm not going to use this. I'm not going to do this integer thing, because there's no reason for that, because it's not a single number anymore. But what I am going to do is I'm going to say code word equals fixing code word. Remember what that does? That makes it in all caps and gets rid of any spaces or anything like that. And I'm going to say print. Got it. New code word is code word. All right, pretty good. But I also need to do something else. As I explained in the last video, I need to create a list now of this code word. It's going to turn into a series of numbers, if you will. So it's going to say, let's fix the new word. In fact, let's do a print here. What is the new code word? Okay, and got it. New code word is, okay, code word. And now what I need to do is I need to say print. We need to first let's turn the code word into a code table. Or code list, actually, sorry, code list. code list of numbers. Okay, that's pretty good. So, and this is what I explained in the last video. So now what I need to do is I need to say for, let's see, you know what I need to do? I need to make sure that my code word, well, I need a new thing. I need a new variable. So not only do I need code word, I need something code word list. Code word list equals the empty list. And I better make sure that it's always the empty list whenever I do this. Whenever I'm resetting the code, I better make sure the code word list is an empty list as well. So I'm going to go here and I'm going to say into a code of list numbers. So I'm going to say code word list equals, boom, I'm resetting it to nothing. And then for letter in code word, I need to go through the letters of the code word, and I'm going to do something with each one of those letters. I'm going to say I equals alphabet dot index and letter. So I'm looking up the letter. And now that I have I, I'm going to say code word list equals code word list, excuse me, dot append I. So a list, the way you add things to a list is with this function called append, and append adds items to list, to a list really. So now I have a list of numbers, which is my code word list. And I can get a blank line in there, and I'm going to say print my list of numbers for encoding / decoding is print code word list. So I'll just print out the whole list. And that's the end of this. So then I just have to say choice equals none, just like before. And I can get rid of this one. I don't need two of them. Now, remember how I entered, or I got from the toolbox time, I got this thing called sleep. Well, I'm going to use sleep here between each one of my prints. So, got it. New code word is code word. And then I'm going to say sleep. And I define sleep in seconds. So I'm going to say, please wait 2 seconds here. And then add a line. Then I'm going to say, I'm going to wait again here. Or actually, I'll wait again here. Sleep 2 seconds. My list of numbers for decoding is print word list. And then I'm going to say sleep, 5 seconds at the end. So you can actually see what those numbers are. So let's go ahead and see if I got this working. Did I get choice 1 functioning? So I can hit stop, hit run, choice 1. Enter, what is the new code word? Okay, the new code word is snowy is awesome. Okay, first thing it's going to do is it's going to fix it. Got it. New code word is snowy is awesome. Okay, object. None type object has no attribute append. What did I do here? Code word list dot append. Code word list equals code word list. Oh, yeah, you don't do it this way. You just do it like this. Code word list append I. Just like that. All right. Let's try this again. Enter a, oh, I have to change this. It shouldn't say enter a new shift number. Stop. It should say in choices, enter a new code word. Okay, so let's run it again. Enter a new code word. So here's my new code word, or I'm going to say, yes, I'd like to enter a new code word. Great, what is a new code word? Snowy is cool. Okay, so the new code word is snowy is cool. First, let's turn the code word into a list of numbers. My list of numbers for encoding decoding is, okay, I think I'd like it to delay just a little bit longer. So I'm going to put a little bit more sleep in here. I'm going to make this 3 seconds, make this 3 seconds, make this 7 seconds. All right, let's try it again. All right, enter a new code word. What is the new code word? It is snowy is cool. Okay, new code word is snowy is cool. First, let's turn the code word into a code list of numbers. My list of numbers for encoding decoding is perfect. And now I can encode well, I haven't written it yet, but I will want to be able to encode a message, decode a message. So let's take a look at encoding. All right, so first it goes input, what would you like to encode? Okay, let's encode. Let's put a print here. Actually, let's put a sleep 3, and then a print for a space. Okay, let's encode message. That's fine. First, let's fix the message. We'll put another sleep 3 print. First, let's fix the message and print sleep 3. The adjusted message is, okay, now here's the part that's a little bit tricky. I don't just shift by shift. I need to shift each letter by a different number in the list. So there's that list of other items. So I need another variable. So instead of just I, now I'm going to have j equals 0 as well. And I and j, little letters like this that are variables, I and j are typical numbers or typical variables used by programmers to show that the variable will only be used quickly and then erased. All right. So what I'm going to do here is for encoding, I'm going to say, okay, let's encode message. First, let's fix the message. It's fixed. The adjusted message is, okay, 4-letter in alphabet. I equals, oh, so I'm going to use j. So I'm going to set j equal to 0 again, just to make sure. And j is going to track along my list of numbers. So the list of numbers is the code word list. So let's see. 4-letter in message. I equals alphabet index letter. I equals I plus, now I'm going to do code word list j. So it's at 0. It's the first item in the thing. And I equals I modulo 26, and the new message is here, and j equals j plus 1. All right? So the encoded message uses the code word, encoded message, new message, and then I'm going to erase the message. I'm going to erase the new message. I'm going to get the choice to be null again, and just for good measure, just to be really careful, I'm probably going to set j to 0 again, j equals 0, just to make sure it's always 0 at the beginning of this thing. And I think that's going to work. Let's see. Stop and run. Okay, so I would like to enter a new code word. Here's my new code word, 1. My new code word is A, so I'm not going to shift anything. Okay? And got it. My new code word is A. Perfect. And it converts it into a list of numbers, which are all zeros. Beautiful. And now I'm going to encode a message. What message would you like to encode? Hi. Okay, hopefully it's going to come out as hi. Okay, let's encode hi. First, let's fix the message. Oh, first let's fix the message. Message fixing, print. Whoa, that didn't really work, did it? First, let's fix the message. The adjusted message is hi. Okay, the adjusted message is message. And then I need to sleep here. Sleep 3. 4-letter in message, new message. Okay, and sleep 3 here. The encoded message uses the code word encoded message, new message, and sleep 7. So I can actually see what's happening. Okay, let's try it again. All right, so I'm going to enter a new code word. The new code word is going to be A, 5 A's. It's not going to shift it at all. And so it's got 5 zeros. That's good. In that list. All right, now I'd like to encode a message. And the message I want to encode is hi. Okay, let's encode hi. First, let's fix the message. The adjusted message is capital HI. The encoded message uses the code word AAAA. Encoded message, hi. Okay, really good. All right, I want to put an extra print here. Let's test it with something longer, though. Hi was a pretty short message, so let's stop that and run. Let's try it again. Enter a new code word. AAAA. That's 5. Good. And let's try a longer message, something. Okay. You can adjust these sleep delays if you want. Okay, so now I'm going to encode a message. And I'm going to encode hello world. Let's encode hello world. So far, so good. Let's fix the message. The adjusted message is hello world. Perfect. And whoa. List index is out of range. Oh, so J, I know what J is here. J went from 0, and then it went to 1, and then it went to 2, and then it went to 3, and then it went to 4, and that's the last item in the list, and then it went to 5, and that's out of the list. So I shouldn't do J equals J plus 1. I actually should do this. I should say if J is less than length of the list, code word list, minus 1, then J equals J plus 1, else J equals 0. Because I need to kind of reset it in that list. I need to go around and around and around. So if the list, remember here's the list is 0, 0, 0, 0, 0. When I do hello world, I change the H by 0, I change the E by 0, I change the L by 0, I change the second L by 0, I change the O by 0. Then I have to change the W by this 0. So I need to reset this J to 0. So let's make sure this works now. Let's test it with a few different things. Bad. Else, oh, whoops. I have to put a colon there and go like that. Okay, so I'm going to enter a new code word. Bang. What is the new code word? It is AAA, only 3 letters. And it should end up with three zeros in that list. Okay, now I'd like to encode a message. Hello world. Okay, let's encode hello world. First, let's fix the message. The adjusted message is hello world, all caps. The encoded message uses the code AAA, and we got hello world out. Okay, that's good. Let's keep testing it though. So now I'm going to enter a new code word. And the new code word is AB, AB, AB. So I'm going to shift every other letter by 1. Okay, so got it. So it should be 0, 1, 0, 1. Good, good, good. Perfect. And now I'm going to encode something. What would you like to do? I'd like to encode a message. What would I like to encode? Hello world. And it should be HFLMO. Yep, HFLMO, and then world, W becomes X, O becomes O. Yeah, it worked. Okay, awesome sauce. All right, now what we need to do, now that we've got this working, so we've got encoding working. So what I'll do is I'll just copy all of this, this whole thing, and whoa, not that. I will get all of this. So that's all of my encoding. I'll hit Command Copy, and I will replace all of choice 3 here. I'm holding down the Shift key while I scroll down. I can hit Command V to paste it in. So I now need to change this to 3, and I'm going to change this to decoding. What would you like to decode? Decode. And okay, let's decode. All right, first let's fix the message. The adjusted message is for, oh, I have to change this to a subtraction, remember? Because for decoding, I need to subtract by the code number. And I have to say here, probably I should, just for clarity, I should say use addition, add for encoding. All right, now decoding, what would you like to decode? The adjusted message is, okay, the decoded message, and finally decoded message. All right, let's see if it works. Ready? Moment of truth here. I would like to enter a new code word. All right, my code word is going to be snowy. So those are the numbers. Okay, now the Nazis, when they were using the Enigma machine, their codes also were only 5 letters long. So you can imagine that this would be a much harder code to crack if my code word was longer than snowy, right? But right now, my list only has 5 things in it, and Y is 24, X, Y, Z would have been 25, so that's perfect. Okay. So now I'm going to encode a message. I'm going to encode my message. All right, what would you like to encode? Mr. Maltzman is a serious doofus. Can't believe you wrote that. All right, Mr. Maltzman is a serious doofus. Okay, so it's first going to turn it into a sentence with no spaces and no capitals and no punctuation. Mr. Maltzman is a serious doofus. Much harder to crack a code that is all one long word, of course. The encoded message uses the word snowy, and here's the encoded message. And let's go ahead and see if it really works. So I'm going to copy this. Oops, rats. I'm going to go up here. Hopefully it'll let me do it. No! It won't let me do it? It won't let me go up here and get that message? It's so lame. There it is. I have to hold it down. Okay, so I just copied that. Hopefully I copied it. Please. All right, so now, just to make sure it really, really works, I'm going to enter a new code word. All right, here's the new code word. It's code. So let's say I thought the code word was code. And now I'm going to try to decode the message that I had a second ago. So I'm going to try to decode the message. 3. And I'm going to paste the message that I just got. And it's going to try to decode it. Okay, let's decode this. First, let's fix the message. Fine, blah, blah, blah. Okay. And it's still a bunch of gobbledygook, impossible to understand, because code was not the code. Snowy was the code. So let's go ahead and enter a new code word. Let's try snowy. All right. And so I'm going to decode the message. Here's the message again. And it actually decoded. Now you may ask yourself, how did the English ever crack this? How did this machine actually work, the one that we're learning about in the imitation game? The way it worked is they would try little slices of code. So we know that the code word is actually snowy, but let's enter a code word that implies that we don't know that the code word is snowy, but we do know that it's 5 letters long. So let's try S-N-O and then F-F. So we know it's not snoff, but we do know that the first 3 letters are right. Let's see if you were a cryptographer, if you could figure out kind of the rest of the code by knowing part of the code. Let's see. So we think the code word is snoff instead of snowy. And now we're going to try to decode the message that we intercepted. Mr. Maltzman is a doofus. So we're going to decode the message. And here's the message we're going to decode. Command V to paste it in again. And let's see what happens. We only have 3 of the correct letters of the code. And Mr. Mal, let's see. Oh, there it is. Mr. Z is not very close, actually. Pretty hard. Mr. M. So the first 3 letters are correct. S-N-O. Then these 2 are wrong. Mr. M-A-L or M-A-L-T-Z-M. Right? So you can actually see that it gets closer. But if you knew one of the words, if you actually knew what one of the words was in the message, let's see this. Okay, let's try this. We're going to enter a new code word. So here's our new code word, and it's snowy. And if you knew that every message contained the word Hitler, not a great guy, but in World War II, the Germans probably had a lot of messages that contained Hitler. So we're going to encode the message, and that's how they cracked the imitation, at least in the movie, The Imitation Game, that's what they use. So I'm going to encode a message, and the message I'm going to encode is Hitler. Now, if we knew that that was the message, right, and we now copy it, we can actually figure out what the code word is. So let's enter a new code word that is not the correct code word, but it's kind of close to the correct code word, like snuff. Okay. And now we're going to attempt to decode using the wrong code word. The same code as before, and we know that the word should be Hitler. Like, we know that. So we are going to decode the message. What message would you like to decode? That's the encoded Hitler. And the decoded message is HIT blank blank R. So we have just determined that our code, snoff, is wrong, but if we know what the message contains, or if we even know that this phrase is somewhere in the message, then we can start to figure out our code, And we might say, okay, well, it looks like these three letters are right. And let's start playing around with these letters and see if we can come up with something until we get Hitler. And that's basically what the machine did. And that's how the English really won the war. I mean, this technique is really what happened. So that's it for the polyalphabetic cipher. I hope you enjoyed making it. I know it's hard, but we're going to duplicate this. And this is going to become the poly cipher with menu 2. It's already made one. Boom. Okay.